Hello, and welcome to the FireVoxel tutorials. In this tutorial, we will show you how to use FireVoxel to create, manipulate, and save vector ROIs, generate vector ROIs from raster ROIs, and use vector ROIs for measuring distances and cropping images. In FireVoxel, vector regions of interest, or VROIs, are rectangular regions of interest that are based on points and lines rather than voxels. Vector ROIs are used for cropping, measuring distances, and co-registration based on fiducial landmarks. Let's load a set of DICOM images. And save them as a FireVoxel document. This is a contrast-enhanced abdominal Dixon image. It consists of 4 sets of 3-dimensional images acquired with 4 different contrasts: opposed phase, fat, water, and in phase. The contrast plays the role of the 4th dimension, like time in a time series. Let's create a VROI to enclose the left kidney. To do this, click the Construct Vector ROI icon on the main toolbar. Now click on the image. This point will be the lower left corner of your VROI. Now, drag the mouse towards the upper right corner and click again. And you have created a VROI. The handles on the lower left and upper right corners allow you to change the size, shape, and position of the VROI. The handles are visible when the VROI is active and disappear when the VROI is inactive. To activate the VROI, left-click on it. And to deactivate it, click outside. To resize the VROI, first activate it, click on either one of the handles and drag it, and then release the mouse. To move your VROI without resizing it, activate it, hold down the right mouse button, drag the mouse to the new location, and release. You can control your VROI using the VROI Properties panel. To open it, double-click on the VROI. Here, you can enter the VROI name, which is useful for annotating the VROIs. You can also change the VROI color by double-clicking the color swatch and selecting a new color. The boxes below show the VROI size and location currently given in voxels. The coordinates are the X, Y, and Z coordinates of the handles on the VROI corners. All coordinates are measured starting from 0, and therefore our slice 41 has the Z coordinate of 40. The dimensions are the lengths of the VROI sides. In this case, the width and height of the axial plane and the depth in the slice dimension. Our VROI is defined only on one slice, and therefore its dimension in the Z direction is 0. The center is the coordinate of the VROI center, where the 2 diagonals intersect. The time interval specifies the range of points in the 4th dimension to which the VROI applies. Right now, our VROI applies only to the first set of images, which have the t coordinate of 0. The buttons at the bottom allow you to place the VROI in the image center, extend it to the full volume, or scale its dimensions by a factor. Right now, our VROI is defined only on a single slice for one image contrast. Now let's extend the VROI in 3 dimensions to include all slices that contain the left kidney, and in the 4th dimension to include all image contrasts. The left kidney is visible on slices 4 through 60. Now, let's open the Properties panel and make sure that the units are voxels. Now we need to enter 3 and 59 as the range of the z-coordinates of our VROI. And now we have a 3-dimensional VROI. To apply the VROI to all 4 image contrasts, enter 0 and 3 as the range of time points, or click All Time Points. And now, our VROI has been extended in the 4th dimension. To examine the VROI in the 3 orthogonal planes, click Display Orthogonal Projections. Make sure that the 3D crosshair is on. To turn it on, select File, User Interface Options, Multi-Projection Synchronize on left mouse click. On each plane, you can adjust the size and position of the VROI in the same way as you would do it on a single slice. We can also create VROIs from an existing raster ROIs. Let's load a previously saved raster ROI delineating the right kidney. Let's open the Layer Control panel, click Load Image, and select the ROI file. And here is the right kidney raster ROI. To create a vector ROI based on this mask, use the main menu and select Vector, Enclose Connected Components by Vector ROIs. And now we have a new vector ROI enclosing the right kidney. We can select for it a different color and give it a name. We can use VROIs to compare the sizes of the left and right kidneys. Let's minimize the axial and sagittal views and measure the dimensions of each kidney on a coronal plane. Let's adjust these VROIs so that they just fit over the kidney length. Now we can open the Properties panel for the left kidney, set the units to millimeters, and record the depth for the left kidney. And then do the same for the right kidney. Open Properties and record the depth. So on this slice, the left kidney is 106 millimeters and the right kidney is 100 millimeters long. The easiest way to save a VROI is to save it within the FireVoxel document together with the base images. Let's save this document and close it. If we reopen it, the VROIs will be restored. You can also use the vector group on the main menu to save and load VROIs. To save your ROIs as a .vroi file, select Vector, Save Vector ROIs. Let's delete our VROIs either by activating each one and pressing Delete, or using Vector Delete All VROIs. To reload your VROIs, select Vector, load Vector ROIs, and select your file. Now, let's open the .vroi file. This file contains the labels, the time intervals, and the handle coordinates for each VROI. You can import this file into Excel or another statistical package and use it to analyze the coordinates of the organs enclosed by the VROIs. We can use VROIs to crop the image outside the organ of interest. Let's crop the left kidney. First, let's make sure that the VROI encloses the entire left kidney in all three planes. Now, let's select Volume, Crop, Crop with 4D Vector ROI, All Layers. And here we have a new window with cropped 4-dimensional images of the left kidney. We have come to the conclusion of this tutorial on vector ROIs. VROIs are convenient for selecting parts of the image, measuring distances, and cropping. For more information, please visit the FireVoxel website. Thank you.